Hello everyone. In previous lecture we had picked that there are three ways I can design rules, that is by decoding push operation, by decoding pop operation, and by decoding no change operation. Now let's take one example. Once again, I had picked the same example which I had started in the previous one, that is a to the power n, b to the power n, which says equal number of a's and b's, where a will be followed by b. Now let's take, suppose I have one string a, and b. Now this string certainly belongs to this language. So how this string will get processed in this particular PDA? So first of all, I am going to showcase you that how this string will get processed, and then we will move that how to design proper rules for this language with respect to push down automata. So what I'll do, once I'll get any A, I'll insert this A into stack and move my pointer to the next cell. Now, if next cell is again pointing to A, what I'll do, I'll insert it, or I'll push it again, and I'll repeat this thing. Once again, I'm going to repeat this whole thing, whole operation, until and unless all the A's got over and inserted or pushed into my stack. So I got all three A's inserted in my stack. Now what will happen once I'll get B? Now what I want, if number of A's are equal to number of B, it means that whatever number of A's got inserted into my stack, once I'll delete A for each and every B, at the end, once B's get over in my stack, I should not have any A left. So that is the whole point which we are going to use. Once we had learned the counting and addition subtraction, we had utilized for minus in our first class, I would say, that suppose now in first class faculty asked that tell us that whether these are equal or not. Now at that point of time we don't know that what is counting. So what we do actually, for every single one we used to cut 1 0, and at the end, if for all ones we have cutted all 0 and there is nothing left, we say that yes, these two are equal. Same fundamentals have been used to design push down automata. Here what we had done, for each every one we are going to insert into the stack, and for 0 we are going to pop 1 from stack until and unless we are getting the final things, or both get null. If any one get left, we'll say that these things are not equal. So same operations we are going to perform. For 1b we are going to pop 1a, and after that we are going to repeat the same thing. For this b we are going to pop this a, for another b we are going to pop this a. Now at the end, if all b's are over, means there is nothing left, which we represent by null. And at that point of time, if my stack is representing null, which is empty stack, which we had given one tuple, that is z0, then we'll say if this condition met, then number of a's are equal to number of b's. Now let's try to design rule for it. How to design rule? So let's see. What we want, first of all, we want to insert element. So at the start, definitely my stack is empty and my current pointer is pointing to A. So what I want at that point of time, I want to insert this A, and we had picked in our previous lecture that how to proceed with that, that is A Z naught. Now the thing is, we had pushed one A above empty stack, that is represented by Z naught. Now the question comes that do we need to make change into my state? Now it depends and it varies for question to question. It's not necessary that for all questions we need to make change in my state, and similarly opposite is also true, that it's not necessary that for each and every question we do not require to change this state. So depending upon question, we need to be careful for making decision that which state I need to take here. Now, once I have inserted one A, so definitely now my top position got A, hence I require another rule for insertion of another A because top of the stack got changed, so I have used this Q naught AA. Now this becomes recursive and repetition. So now after this, whatever number of A's I am having, it will insert each and every A. Now what will happen once I'll get B? So definitely my top of the stack is A because I have inserted all the A's. So for B, what I'll do, I am going to delete one B, delete one A for each and every B, and here I have made one small change into my state. Now why I have made change into my state? The reason is that suppose if I'll write similar Q naught null, what will happen that AB, this will get accepted. Now I'll discuss this thing in my next once I'll represent all the rules, I'll discuss it again. Currently I am only focusing on few rules, that how to design rules. Now similarly, if I am having Q1 null Z naught, which means I had picked earlier that my input tape is empty and my stack is also empty, it means I got into final one, and hence I am not going to make any change into my state. So that is how we are going to design rules for it. So let's pick that what will be the final rules for the same problem. Now here I have designed rule. What we had picked, that Q naught A Z naught, what I am going to do, I am going to make one small change, that is I am going to make change in my state. The reason is that I don't want that everything get performed in Q naught only. I want that after inserting first A, everything should get moved into the next state. So I have picked this in Z naught. Now once I have Q1, so I already know that 1A is already inserted. So I'm going to use one repetition so that I can insert all the rules. After completion of all the rules of insertion, what I'll do, now I require deletion. For deletion, what I have done, Q1BA, which says make it null, and again I am going to make change into my state. Once again I'll take one example to prove that why I had made change here, and further Q2 null, because here one Q2. So for further repetition of B and A, deletion of A for each and every B, I require Q2. Finally, once I'll move into the final one, when input tape and stack both becomes empty, it means we got or desired result, that is equal number of A and equal number of B. Hence, we will move into the final state with QF with no change in state, no change in stack. Now, let's see that why we require to change state. So let's suppose the same rule which I have given earlier, without making any change in my state, I have represented that Q naught. If I'll got A, Z naught, I'll insert it. If I'll got double A or stack A and input A pointing, then definitely again inserted. For B, I am going to delete, and for null, I am going to utilize this thing. Now, definitely these rules are less in number, and they can perform everything which can be performed by A to the power n, B to the power n. But the thing is it the right set of rules for this particular language? The answer is no. Reason, these rules are superset. They can perform much more than the A to the power n, B to the power n. Now let's take one example which I had earlier said, A, B, A, B. Let's try to perform this thing. For first A, my first rule will get deployed and A will get inserted. For B, once my pointer is pointing to B, my state is Q naught, so I am going to check that in Q naught B and top of the stack is A, what I should do? My third rule says that you can delete this A. Hence, my stack got empty, and since it got performed, my input will move into A. Now, again, because state do not get changed, so if input pointer is pointing to A and stack is empty, so rule number 1 get applied and A will get inserted. Similarly for B, this will get deleted, and at the end, because there is blank and my input tape is also blank, my final rule get applied and string get accepted. Now, is this a string belongs to A to the power n, B to the power n? The answer is no. Reason is that yes, we have equal number of A's and equal number of B's, but A will be always followed by B. But in this example, A is not always followed by B. Here, B will be followed by A also. So it means this particular set of rules can perform much more than the desired. Hence, these rules are not right for this particular language. So I hope now you got that how to write rules and how to identify that whether rules are written in a proper way or not. What is the significance of state? So I hope you got each and everything. So this is how we design push-down automata.